So in this video, we're going to practice some problems associated with finding the equations of tangent lines, the equations of normal lines, and the equations of horizontal lines. So beginning with the first problem, we are asked to find the tangent line to the curve at x equals 3. So as background for this problem, you should know that the tangent line is always given in the form y minus y1 equals m times x minus x1, which is point-slope form. So the coordinate point is represented by x1 and y1, and the slope by m. So these three variables will be replaced by numbers. Actually getting to the problem, we already know that x equals 3, and to find the other half of the coordinate point, or the y value, we can plug x1 equals 3 into the original equation. So we're going to end up with a y value of 24, which can just be rewritten instead of y of 3 equals 24 as y1 equals 24. Now, to find the slope, we are going to take the derivative of the original equation, which will give us dy over dx equals 2x plus 5. So when you evaluate the derivative at 3 to determine the slope at this point, you are going to end up with 11. So after all these calculations, your final answer and the tangent line to the curve at x equals 3 is y minus 24 equals 11 times x minus 3. So this answer is sufficient for the AP Calculus exam. However, if you would like to simplify it, you absolutely can. And in that case, it would be y equals 11x minus 9. So in this next problem, we're asked to find the equation of the normal line, which is the negative reciprocal of the tangent line. So we're going to approach this problem in the same manner as the last problem for the first few steps. So for the point-slope form, again, we are given an x value that we can plug into the original equation to find a y value. So when we plug in 1 as our value of x, we are going to end up getting that f of x, or f of 1, is equal to 4, which again can just be rewritten as y1 equals 4. Next, we are going to find a slope again, which means we're going to take the derivative. So the special case with this specific problem is that one of our x values is in the denominator. So if you recall, whenever there is a variable in the denominator, you are able to just raise it to a negative power. So we're going to rewrite this as f of x equals 3x to the negative 1 plus x. And then that makes it a lot easier for us when we go to take the derivative. So now we're just going to use the power rule, take our derivative, and we're going to end up with f prime of x equals negative 3x to the negative 2 plus 1. So then we're going to evaluate it at x equals 1, so we know the slope when x equals 1. And we're going to end up with f prime of 1 equals negative 2. So that's going to be our slope value. So this is not our final answer, as you may recall that we are looking for the normal line. So we must take the negative reciprocal to find the slope of the normal line. So we're going to end up plugging in all of these values, as you can see over here on this side, into the normal line point slope equation. And we're going to end up getting y minus 4 equals 1/2 times x minus 1. Again, you can finish out this problem completely and get y equals 1/2 x plus 7/2, but that's not necessary for the AP exam. In this next question, we're asked to find any horizontal tangent lines on the curve. So horizontal tangents occur when the tangent line is horizontal to the curve and has a slope of 0. Now, if you recall from the previous problem, you can calculate the slope of the derivative to get the derivative of the original function. So first we're going to do that. We're going to end up with dy over dx equals 4x cubed minus 4x. And we're going to set that equal to 0 to find the x values where the horizontal line occurs. So we're going to factor that out completely. And we're going to end up with x equals 0, x equals 1, and x equals negative 1. This answers the first question asking if there are any horizontal tangent lines that exist. And yes, the curve does have a few horizontal tangent lines. It has 3 to be exact. So in the second part of the question, it asks us where the horizontal tangent lines exist, or the equations of the tangent lines. So we already have our x values, and we know that our slope is 0 because it's a horizontal tangent. So we just need to solve for the y values. So we can plug each of the x values into the original equation. And then we would end up with when x is 0, y is going to be 2. When x is 1, y is going to be 1. And when y is negative 1, x is negative 1, y is also going to be 1. So the equations of our tangent lines are going to be at y equals 2 and y equals 1. In the next problem, we're going to deal with the question in a few parts just to make it easier for ourselves. So for the first part and the first statement, we're asked to find any time at which the function or equation has a slope of 4. So we're basically looking for all the points on the function where the derivative is equal to 4. So first we're going to determine the derivative, which is dy over dx, which is also equal to y prime, as I've mentioned before. But that's going to make it a little easier for the later part of the problem. And that's going to be 3x squared plus 1. So now we're going to set that equal to 4 to find any points at which the slope is 4. And that's since the derivative is equal to the value of the slope. So when we solve for x, we are going to end up with x equals both positive or negative 1. So we're going to solve for the equations of these tangent lines, which will give us our y value. So you can see here that when x is 1, y is 2, and when x is negative 1, y is negative 2. You can use these plus the slope of 4 to write our point slope form tangent line equations. So we're going to end up with y minus 2 equals 4 times x minus 1 when x is 1, y is 2, and the slope is 4. And then when x is negative 1, y is negative 2, and the slope is 4, we're going to end up with a tangent line of y plus 2 equals 4 times x plus 1. So in the second part of this question, we're looking to find the smallest slope on the curve. So basically it's asking us when the derivative is the smallest. So we already have the derivative equation from part 1, and we're going to use it again. But this time we are going to use the graph of the derivative, which will look like this, and you can use your calculator to do the same thing. Just plug in this 3x squared plus 1 into your calculator, and you can see the equation, the graph of the derivative. So the smallest value of the slope in this case will be the minimum or the vertex of the parabola. So with this particular parabola, the vertex occurs when x is 0 and y is 1. So at that point, y prime, or the plottings of our slopes, is 1. So therefore, the value of x that the curve has the smallest slope of 1 is 0. So that answers both the second and the third question. And those are common problems surrounding tangent lines. Here to finish this off, this is a little bit about me.